what are the major causes of flight turbulence? Flight turbulence is directly caused by air turbulence. Air turbulence is described as atmospheric spaces in which there exist vertical winds, including both upward winds and downward winds, appearing alternately. In contrast to the usual belief that winds blow horizontally only, in reality, winds can blow vertically in the higher layers of the atmosphere. If an airplane hits upward winds, the lifting force exerted on it increases. The sudden increase in the lifting force results in the sudden increase in the airplane's altitude. Usually, right after hitting an upward wind, the airplane will hit a downward wind, which results in the decrease in lifting force leading to the decrease in altitude. The increase and decrease in altitude appearing alternately is called flight turbulence, like what happens when your cars are running on a road with many potholes spaced evenly. So, what are the hidden culprits of these vertical winds? The direct culprit of the vertical winds is the difference of air temperature among adjacent atmospheric spaces. If temperature of the air in an atmospheric space is hotter than the surroundings, the air expands and becomes lighter. Buoyancy force exerted on the air prevails over gravitational force. The air is therefore driven upward, resulting in upward winds. On the contrary, if temperature of the air in an atmospheric space is colder than the surroundings, the air contracts and becomes heavier. Gravitational force exerted on the air prevails over buoyancy force. The air is therefore driven downward, resulting in downward winds. So, what are the culprits behind the difference in temperature among adjacent atmospheric spaces? There are many causes for the difference, ranging from the difference of materials that make up the ground, including the structures built by human, to the difference in terrain, and even the clouds, the variation of sea surface temperature, etc. The following are details of the causes of air turbulence and flight turbulence. 1. Difference of materials that make up the ground. Because different materials have different heat capacity, difference in materials that make up the ground will result in difference in temperature of the material. For example, temperature of the ground that is covered with forests and bodies of water is lower than temperature of the ground that is covered with rock, soil, and sand. The reason behind this is because heat capacity of water is around 4,200 joule per kilogram Kelvin, which is much higher than heat capacity of rock, soil, and sand, which is less than 1,000 joule per kilogram Kelvin. During sunny days, the lower the heat capacity of the material that makes up the ground is, the higher the temperature of the ground is. So, a ground made of rock, soil, and sand is hotter than a ground made of forests or bodies of water during daytime. If a ground is hotter than the surroundings, the air right above it is also hotter than the surroundings. If these different grounds appear alternately and an airplane is flying close enough to these grounds, it may encounter flight turbulence. 2. Structures built by human. Another cause of the variation of temperature of atmospheric air is the structures built by human. If all air conditioners of big structures like towers, condominiums are turned on, they will emit a significant amount of heat to the atmosphere. This amount of heat heats up the surroundings and causes upward winds. Many industrial plants, like power plants, also emit significant amounts of heat too. Another way that a building can heat up the atmosphere is because of its own color. If walls and roofs of a building is painted with black paint, black color will absorb solar radiation of all wavelengths, and being heated up quickly. Hot walls and roofs of the building, in turn, heat up the surrounding air by conductive heat transfer, making the air very hot. Meanwhile, if the walls and the roofs of the building is painted with white paint, white color reflects most of solar radiation of visible wavelengths, and maybe ultraviolet wavelengths too. White walls and roofs are therefore not heated up so much, and the surrounding air's temperature is cooler than that of the black walls and roofs. So, if black buildings and white buildings are situated alternately in a row, and an airplane is flying close to the top of the building, it may encounter flight turbulence. This may happen around airports where airplanes are usually at low altitudes. 3. Mountains. Mountain is another cause of temperature difference in the atmosphere that results in flight turbulence. Mountains play the role of fins of heat exchangers. Mountains facilitate the liberation of heat energy in the form of infrared radiation. That is why peaks of mountains are very cold. And that is why clouds usually gather around mountain peaks, even the mountains are around half of a mile in height. Meanwhile, Flat lands are hotter than mountains because flat lands do not facilitate the liberation of heat energy. So, if mountains and flat lands appear alternately, they may cause air turbulence above them, and if an airplane is flying over them at low enough altitudes, it may encounter flight turbulence. 4. Clouds. In addition to what happens on ground, clouds in the atmosphere may also be hidden culprits of flight turbulence. If a cloud is in a developing phase, water vapor is turned into liquid water in a process known as water condensation. The condensation of water vapor liberates a lot of heat energy known as heat of condensation. This process causes the air right above a developing cloud hotter than the surroundings where there is no developing cloud. The reverse is also true. If a cloud is in a receding phase, liquid water is turned into water vapor in a process known as water vaporization. The vaporization of water absorbs a lot of heat energy known as heat of vaporization. This process causes the air around the receding cloud colder than the surroundings where there is no receding cloud. If a cloud causes rain, the temperature of both the atmospheric space and of the ground below the cloud is also lower than the surroundings, because droplets of water vaporize while they are falling in the air. The difference in temperature between these clouds and their surroundings causes air turbulence, which in turn causes flight turbulence. 5. Ocean currents, tropical depressions, tropical storms. Hot ocean currents and cold ocean currents can cause the variation of sea surface's temperature that results in the development of tropical depressions and tropical storms, which are the most dangerous forms of air turbulence. This is an animation of a tropical storm. At the core of the tropical storm, the I-shaped column, air is moving upward. And far from the I-shaped column, air is moving downward. Usually, except for cyclones like tornadoes, tropical storms, hurricanes, other causes of flight turbulence may not be so dangerous for commercial airplanes, because commercial airplanes can make use of their own kinetic energy to boost the lifting force in the case they encounter downward winds, by extending their flaps on their wings to gain more lifting force. Also, the velocity of a commercial airplane is fast enough to let it quickly pass through the air turbulence that it encounters. However, air turbulence is very dangerous for helicopters because helicopters cannot make use of their own kinetic energy to boost the lifting force. All lifting force of a helicopter comes from its engine. In addition to this, helicopter velocity is quite slow. Around the world, there have been many helicopter crashes in mountainous areas where air turbulence is caused by the difference in temperature between mountains and flat lands around them. Air turbulence usually occurs near ground and at altitudes where there are clouds. Usually, clouds appear at altitudes around 5 kilometers, or 3 miles, above sea level. If an airplane flies at an altitude of 10 kilometers, or 6 miles above sea level, or at higher altitudes, it is quite safe from air turbulence. Commercial airplanes usually fly at the altitude of 6 miles or higher, but helicopters usually fly at the altitudes around 3 miles or lower.